Imagine a machine launched when disco music ruled the world, when the internet didn't exist, and when humanity had never seen the outer planets up close. Now imagine that same machine is still alive today. Traveling more than 24 billion kilometers from Earth, in a region so cold and dark that sunlight is barely detectable, one spacecraft continues to send messages home. That spacecraft is Voyager 1. But here's the mystery: how has Voyager survived nearly 50 years in the freezing emptiness of space? Why hasn't it frozen solid? And what secret has kept this incredible explorer alive for half a century? Today, we're diving into one of the greatest engineering achievements in human history. Space is incredibly cold. So why hasn't Voyager frozen? When we imagine space, we often think of emptiness. But emptiness can be deadly. In interstellar space, temperatures can plunge to around -270 degrees Celsius. That's only a few degrees above absolute zero, the coldest temperature theoretically possible. At those temperatures, most machines would stop functioning. Electronics become unreliable. Materials become brittle. Mechanical systems can fail. For Voyager, the challenge wasn't just surviving years. It was surviving decades. And that's where its secret weapon comes in. Voyager doesn't use solar panels. At its current distance, sunlight is so weak that solar panels would be practically useless. Instead, Voyager carries something extraordinary: a miniature nuclear power plant. Known as a radioisotope thermoelectric generator, or RTG, this device contains plutonium-238. As the plutonium naturally decays, it releases heat. Lots of heat. That heat is converted into electricity that powers the spacecraft. But here's the amazing part. Not all of the heat is turned into electricity. A large amount remains as warmth. Essentially, Voyager has been carrying a built-in heater since the day it launched. For nearly 50 years, that tiny nuclear heart has kept the spacecraft alive. Without it, Voyager would have frozen long ago. Generating heat is only half the battle. Keeping that heat is equally important. That's why NASA engineers designed Voyager with incredible thermal insulation. Think of it like an astronaut wearing the world's most advanced winter jacket. The spacecraft is wrapped in special materials that trap heat inside and prevent it from escaping into space. Every watt of warmth is precious. Every degree matters. And thanks to this insulation, Voyager has remained warmer than many scientists expected. In fact, some instruments are operating in temperatures colder than their original design limits and still functioning. That's astonishing. But Voyager's survival isn't automatic. Every year, its power supply becomes weaker. The plutonium fuel is slowly decaying. As a result, the spacecraft loses electrical power year after year. NASA engineers have had to make difficult choices. To keep Voyager alive, they have gradually switched off non-essential systems. First went the cameras. Then various scientific instruments. Then backup systems. Piece by piece, the spacecraft has been stripped down to only its most important functions. It's like keeping an ancient car running by removing everything that isn't absolutely necessary. Every watt saved means more years of life. Every decision helps delay the inevitable. What's truly remarkable is how often Voyager has surprised everyone. Over the decades, engineers have faced numerous problems. Computer glitches, aging hardware, failing components, communication issues. Again and again, people feared the mission was ending. And again, Voyager fought back. NASA engineers have even reactivated thrusters that hadn't been used for decades. Imagine turning on a machine that has been sitting idle for over 30 years and having it work perfectly. That's exactly what happened. Voyager keeps doing the impossible. It's almost as if the spacecraft refuses to give up. In 2012, Voyager 1 achieved something no human-made object had ever done before. It entered interstellar space. It crossed the boundary where the sun's influence begins to fade and the vast ocean between the stars begins. Today, Voyager is exploring a region humanity has never visited before. A place filled with mysterious particles, cosmic radiation, and conditions unlike anything found within our solar system. Every bit of data it sends back is a message from the frontier of the unknown. It's humanity's most distant ambassador. A lonely traveler carrying a golden record filled with sounds, music, and greetings from Earth. A message to whoever, or whatever, might someday find it. Unfortunately, even legends cannot live forever. Voyager's power supply continues to decline. NASA estimates that sometime during the next several years, more instruments will need to be shut down. Eventually, there won't be enough electricity to power its transmitter. When that day arrives, Voyager's voice will fall silent. The spacecraft will stop communicating with Earth forever. No final message. No dramatic farewell. Just silence. But its journey won't end. Voyager will continue drifting through the Milky Way for millions of years. Long after Earth has changed beyond recognition. Long after today's civilizations are gone. Long after humanity's current era becomes ancient history. Voyager will keep traveling among the stars. So, why hasn't Voyager frozen after half a century? Because of a tiny nuclear heart. Brilliant engineering. Exceptional insulation. And the dedication of generations of NASA scientists who refuse to let it die. Voyager was never supposed to last this long. Yet nearly 50 years later, it remains alive, exploring the darkness beyond our solar system. A testament to human curiosity, human ingenuity, and humanity's desire to reach the stars. The real mystery isn't why Voyager hasn't frozen. The real mystery is how something built in the 1970s is still exploring the universe today. And perhaps, somewhere far ahead in the future, Voyager's greatest discovery is still waiting. If you enjoyed this journey into deep space, don't forget to like, subscribe, and join us for more cosmic mysteries. Until next time, keep looking up.